a few of us haven't done the quiz on 2.1 and 2.2. That's something we got to put on our to-do list. What is a polynomial anyway? This was in grade 10 I taught it, and it was a couple of easy marks. Well, if it looks like that complicated thing, it's a polynomial. What does that say? Actually, that's a polynomial. What? So is that. So is that. Okay, that's a polynomial by definition. But what isn't a polynomial? Specifically, the exponents have to be whole numbers and coefficients are real numbers. So, this you want to remember, because that will be like an easy mark on the test, right? That's not a polynomial. Because, remember, if I want to put x on the top here, flip was the word I used in Math 10, I can put x up there, but I got to change that 1 to a negative 1, and that is not a whole number. Can't have a negative exponent in a polynomial, okay? It looks like that. Root x is not a whole number exponent, because as we remember, the square root of something is the same as something to the half power, right? Put that in your calculator. That's 4. Okay? But we want to know what these things look like. Odd degree function. Let's start off with the most basic thing we know. Is that a polynomial? Y equals x? Sure it is. We both got positive exponents. You know what that line looks like? Of course you do, because you know that's what you would reflect something over if you're talking about the inverse. That looks like this. How about another odd degree function? After 1, our next lowest odd number is? Anyone know what that looks like? I kind of said it. Maybe you saw pictures of it, but maybe we don't have it memorized. Well, actually, before I even graph it, we'll think. If x is 3, 3 times 3 times 3, y is something really big. Goes up there. If x is a negative, anything, what's a negative times a negative times a negative? Let's make that a little clearer. It's a negative, right? And the bigger the x is, the bigger negative it is. So it goes down like that. What happens in here? If x is 0, y is 0. So that thing looks like that. And let's prove it. Y is x to the power of 3. Okay, kind of an S-ish shape. But does that kind of look like the same kind of, well, when I'm talking quadrants, does it look like it goes in the same quadrants as our line y equals x? Do we have any prediction about what this guy will look like? I'll leave that in there. X to the power of 5. Graph that puppy. Pretty similar, only as x gets multiplied by itself 2 more times, well, this is going to be even steeper, isn't it? Okay, the same shape. That's all we're looking at. Odd degree function. Okay, x cubed isn't that much. I just put it like that so that wasn't over top of my line there. Okay. Now, as I add other things in here, that will change the shape of this guy around here. But as far as quadrants, I'm telling you, that's always going to go up in quadrant 1 and down in quadrant 3. Do you know what y equals x to the 17th will look like? It will always go up in quadrant 1 and down in quadrant 3. Okay? What happens if, because this was all positive, what happens if now the leading coefficient is negative? Like, what does that do to y equals x? reflects it over x-axis. Is this something new? Have we learned this? No, we learned that, right? That negative can be put on the y, that's a reflection over the x-axis. So, any ideas what that'll look like? If x is a positive, I'm going to have, like, say 3. 3 times 3 times 3 is 27, but it's going to be negative. It's going to go down there. And it's going to go up there if x is a negative. It's just going to flip it over the x-axis. So everything you see here is going to be reflected over the x-axis, and this is, as far as quadrants go, now going to go up in 2 and down in 4. Okay, so x to the 11 plus, I don't know, x9 minus 32x7. I could graph that, but all this extra stuff's going to do is change this. Maybe give me some more zeros than x-intercepts, but as far as the shape, okay, it's always going to go up, down in quadrants 2 and 4. An even degree function, such as, what's the most basic one we know? Good old y is x squared. We know what that looks like? You should. X-intercept right there, and 1 is 1, 1 is 1, 2 is 4. Okay, looks like that. What quadrants does this go up in? 1 and 2. So any predictions as to what that's going to look like? If x is a big number like 3, I got 3 times 3 times 3 times 3. Even bigger, it's just going to be a lot steeper. Okay, so any positive even degree function where the coefficient is positive is going to look like that. Okay, maybe some strange stuff going on in there if I add this kind of stuff. Okay, but I know it's always going to go up. 2 and quadrants 1. Okay, the bigger the degree just means there's possibly some more x-intercepts and things. And we'll see that in a sec. So, if I now make that negative, we know what that does. That just reflects everything over the x-axis. Okay, this will be different, but I know it's always going to go down quadrants 3 and 4. Okay, even if this thing's got a vertex over here, eventually it's going to go down in quadrants 3 and 4. Okay, I don't care where it is. That always happens. Same thing with this guy. Yeah, I could have a parabola over here, but eventually quadrants 1 and 2 is where this guy's going to go. Okay? All right. Got lots of graphs here. No calculator. Does this look linear? Can I put that in y equals mx plus b? Great, but that's grade 10. Let's do grade 12 thinking. That's the line y equals x. You know what that looks like? Shifted where? Left 2 units. That's it. Okay. Let's check it. Y equals mx plus b. I would start at the y-intercept, 2, and then my slope is 1 unit up, 1 unit of run, 1 rise, 1 run. Okay, same thing, right? How about this guy? Well, let's look at x-intercepts. When's this thing 0? 1, 2, 3. When's this guy 0? -5. Okay, we like that to be factored. It's easier to graph. Is this a quadratic if I multiply and FOIL that thing? Do I get an x squared term? what happens with that? Oh, that's an even function. Always goes up in quadrant 1 and quadrant 2. So I know that thing goes up like that. I know that thing goes up like that. Okay? I just want to be a little more specific as to what's going on in here. What point could I plot in here to find out how low I want to loop this thing? The y-intercept. Always, always, at the y-intercept, x is 0. If that's 0, I get that. If that's 0, I get that. And my y-intercept is, what's negative 3 times 5? Way the heck down there. Okay, which is kind of off my scale. Okay, way down here somewhere. So, but if I did that, that would have been wrong, right? Degree 2. Degree how many? And here's what you got to recognize. In here somewhere, I want to know the degree, the highest degree this thing's going to have. Because that's what determines what shape it has. Okay? So here somewhere, irregardless of what this is when I multiply it, I know that's an x times an x times an x term, which is x cubed, and that's going to make it a negative. Do I know what shape it's going to have? That's always going to go up in this quadrant, and it's going to go down in this quadrant. That's what the previous page told me. But let's be more specific. Where is this thing 0? Negative 4. Where is this 0? 5. And the trickier one, when is this thing 0? When x is negative a half, right? So if we're rusty with that, well, let's check it. Is that thing equal to 0? Negative 1 and 1 is 0. And if you don't see it, some of us are fresh off of Math 11, some of us aren't, then we solve it. When is this thing equal to 0? Let it be equal to 0 and solve it, right? Divide by 2, divide by 2, when x is minus a half. This thing's 0, okay? Minus a half is right there. So I know it goes through those 3 points. I know that's a negative x cubed. Let's go back and look. Odd function negative always goes up in quadrant 2, down in quadrant 4. Can we kind of figure out how this thing's going to go? Like that. Like that. How do I get from this point to this point? To this point? Well, it's got a loop around here. I'm not sure about what happens here, but let's just kind of do that. But here's the point I kind of want to be more careful with, because that is my y-intercept, and that's easy to do. What happens at the y-intercept? X is 0. So that's 0, I got just 1 in there. If that's 0, I have 4. If that's 0, I have negative 5. So that's my y-intercept. What does that give me? 5 times 4 is 20, times 1 is still 20. I have 2 negatives, so that's going to be positive 20, which is way up there. So if I did that, I'm going to say, nope, that's not good enough. That's wrong. That goes way up there. This goes way up here, and they join way up at 20. Okay? No calculator. Would it be hard to figure out more precisely what's going on over here? All I'd have to do is put in x minus, I don't know, 2, x minus 3, and I could figure out that point. I won't do that with this one, but down here I will. Okay? Does that look like the shape of a negative x cubed? You bet. What's the degree on this one? X squared. Positive. I know it goes up in this quadrant, up in this quadrant. Okay, if you like, that's x minus 3 times x minus 3. It says the same thing, right? Where do I have a 0? At 3. 1, 2, 3. And I have another 0 at 3. Okay, so we call this a double root. This is a parabola. I know it's positive. It goes up here in that quadrant. It goes up in that quadrant. But let's be a little pickier. Let's find the y-intercept. That's where x is 0. So 0 minus 3 squared is 9. Okay? Very similar, only power of 3. Odd function, positive. What quadrants does it go up and down in? Who's got it memorized? Up in this one, down in that one. Where's my 0? At 2. And I have 3 of them. That's x minus 2 times x minus 2 times x minus 2. So it goes through there. And where's my y-intercept? That's where x is 0. So 0 minus 2 is negative 2. What's negative 2 cubed? 2 times 2 times 2 is 8, and that's a negative 8, right? Negative 2 times negative 2, positive 4. Yeah, not 12 or 16, whatever you said. Times another negative 2, negative 8. So that's down here. Okay? So it actually, okay, it's not over here, it's over there. What's another way to think about this? That's x cubed shifted to the right by 2 units. Okay? What degree is this puppy? I got an x here. I have 3 x's there. So that's an x to the 4th function. Okay? Even function, is this thing going to be positive or negative? That's going to make it negative. Let's write it. A negative even function. Where's this 0? When x is 4, that's a triple root. And I also have a 0 at negative 1. What quadrants does this thing go in? Negative even function, even function negative, down in 3 and 4. Okay, so that's going to go like that. That's going to go like that. What should I do in between those 2 dots? Y-intercept, where x is 0. So let's just write the whole thing out. So that's still a negative 1, and this is negative 4 cubed, which is negative 4 times negative 4, positive 16, times a negative 64, which is minus 64, which is really, really, really big. Way the heck up there. So this actually should have gone like that. It goes way up there, crosses y-axis at 64, and comes back down. Goes through that guy. Should I see what that plot's like on my graphing calculator, just for curiosity? Okay, because we're getting like 4th powers here. Sure, let's cheat and let's see what that looks like. This picture is worth 1,000 words, right? So negative bracket x plus 1. Whoop, where's my bracket? Bracket x minus 4 bracket cubed. Okay? Looks the same, doesn't it? Sorry? Let's go up to 7. Hmm? What little kick? Well, here you mean? Experience. Don't worry about it. If you got this, guys, if this is a test and that's what you got, that's fine. Well, let me backtrack a bit. This is a triple root. This is a double root. On this, this is where it hits the axis and bounces up, right? Let's put it this way. This is like 3 times the effect that this one is. Is that helpful? I don't know. Sometimes, usually that happens, right? But if we're guys, this is right, okay? Why does it kind of more do that? Because there's a triple root there. This is a triple root here, so it levels off, okay, and kind of goes down like that. That's all I can tell you. Okay? But when I'm marking this, this is what I'm looking at. That point, this quadrant, that quadrant, and I know my y-intercept's way up there, okay? So honestly, guys, if you did this, I would probably still mark that correct, okay? But don't do that. Okay? All right, 3 more. How many x's do we have? I got 1 there. This is going to give me 2. That's going to be x to the power of 3. That's odd. Then you determine, is this thing going to be a positive or negative? I don't see any negatives there, so that's going to be a positive. What's the shape? It's up in this quadrant. Okay, it goes down in this quadrant. Where's my zeros? At 1, at -2. So, looks like it goes through there. Looks like it goes through there. Let's be specific around the middle. Where's my y-intercept? That's where x is 0. Okay, so y-intercept 0, that's just going to be a 2. That's 0. That's a -1 squared. -1 times -1 is +1 times 2 is 2. So it's right there. I'm going to clean that up a bit. So this, remember, that's a double root. So just like this guy, it hits the axis and bounces back up. You notice that? So sometimes you can kind of predict a little bit how that's going to behave, but like I said, all I'm looking at is that point, that point, that point, and what quadrants does it go. Okay? What power of x is this beast? I got 3 x's here, I got 1 x there, x to the 4th, and it's positive, so it's going to go up that quadrant, it's going to go up in this quadrant, just like y is x squared. This has a triple at 1 and a single at -2. Okay, so triple probably hits there and bounces off it and then goes up. But where is my y-intercept? Two times -1 times -1 times -1 is -2. Okay? So again, my experience tells me that this is x to the 4th power. It's not x squared, so it probably doesn't make a nice parabola shape. If I wanted to be picky, I would go, what's happening at x minus 1? Let's put x minus 1 in there. Minus 1 plus 2, minus 1 cubed. Okay, so that's negative 2 cubed times 1, which does nothing, and that's what? Negative 8, which is way down here. Huh. Let's check it out. So, bracket x plus 2 bracket x minus 1 bracket cubed, and then get rid of that guy. Whoops, and change my scale back. Max 10. Yeah, okay. Oh, grief. All right, the last for best. How many x's do I have here? Good. There's 2. There's 2. There's another one. That's x to the 5th. That's an odd function. Is this guy even? Sorry, is he positive? It's not. It's an odd function. Is it a positive or a negative odd function? Positive, okay? There's no minus here. That's a positive odd function. So that thing does the same as x cubed. Goes up here, goes down there. Let's find out exactly what's going on. This is a 0 at negative 4, a double root at 1, a double root at negative 2. So, goes like that, goes like that. How picky do we want to be here? Yeah, well, I want to be picky with this point. The y-intercept, that's 2 squared, and negative 1 squared is just 1. I'm not even going to put it down. And times 4. Okay, so 4 times 4, 16. That's way the heck up there. So it hits here at this double root, bounces off the axis and goes way up there, comes back down, and I guess it goes right through that point, right? Sorry? Okay. What's going on in here? I think I want to plot that point because I'm a good kid and I'm picky. Negative 1, 2, negative 3. What happens at x negative 3? Let's put that in. Negative 3 and 2 is negative 1 squared. Negative 3, negative 1 is negative 4 squared. Negative 3 and 1 is just times 1. That's 16 times 1. Whoa, that's way the heck up there. See how different that is than what I probably would have done? But remember, that's a double root, so at negative 2, it hits the axis and bounces and goes up the other direction. Yeah, it's grade 12, connect the dots. There you go, right? It's not hard. It's just parsnickety. I'm not saying you can't, but this is an accurate graph. What is this thing going to look like? Well, actually, I got a squared button, don't I? Squared, bracket, x minus 1 squared times x plus 4 looks the same, right? Okay, so x to the 5th power can have lots of different zeros. That's what our next table is going to be. Yours is horizontal, mine is vertical. Can I make that smaller? Okay, last thing we're going to do. A constant. How many x's are in here? None. It's a degree of 0. If you like, you can write it like that. Okay, because what's anything to the 0 power? It's actually 1. Actually, so that wouldn't work, would it? I'd have to do that. Okay? Do we know what that graph looks like? 1, 2, 3, 4, 5. It looks like that. Actually, that was incorrect. Here's how I want to write it. Horizontal line has a slope of 0. Y equals mx plus b. How many x-intercepts does this have? None. But it could have an infinite number if this equation was right there. Y equals 0, right? Because then every point is a y-intercept. So that's why it says 0 or infinity. Maxes and mins, none. Domain, all real. Range, just 5. Linear, for example, a line. How many x-intercepts could a line have? Well, unless it's a weird one, I'm just going to say 1, okay? But we know from Math 10, it could have an infinite number, could have a special case up here, okay? Whatever. It's some line. 1 x-intercept. Maxes and mins doesn't really make any sense. Domain's all real. Range is all real, okay? We're just trying to see a pattern here, right? Quadratic. I know quad kind of implies it's 4. Hopefully we all memorized from Math 11 quadratic is 2, right? Y is, I don't know, 2x squared. Y is 2x minus 3 squared plus 2. We've done this. You know where the vertex is? That's at 3, 2. Okay, if it's positive, it opens up, or i.e. goes up in quadrants 1 and 2. How many x-intercepts could I have with a parabola? 2. That's it. This one has none. That's okay. But the maximum number of x-intercepts is 2. It could have a max. It could have a min. But it can only have one of either, right? If it's a negative parabola, we got a maximum. If it's a positive parabola, we have a minimum. But it's either got one max or min. Domain, all real. Y is either greater than or equal to the minimum, or it's less than or equal to the max, right? Whatever it is, where your vertex is, that's where that is. Okay, that we know. What's new to Math 12? Cubics. Y is x cubed. Maybe you got some other junk in there. But you know now the shape of that is determined by the highest degree. How many x-intercepts could I have? Goes up here. It could have 3 x-intercepts. Do you see a pattern here? And again, technically this does not have a maximum, but when we taught it in grade 11, we said it had a local max, okay, and maybe a local min. No. Oh, I mean, sorry. This was in the old Math 11 curriculum. And we used to, I don't see it in this book, so I don't think we need to worry about it. Does this have a max? No. Does it have a min? No. And neither did my line, did it? Or sorry, this one. Okay, this one had no max or min. Didn't really make any sense. So I think that's where we're going now with this course. But I haven't completely taught this whole chapter, so if we come back to this local stuff, don't kill me. X is all real. What's my range? All real. Just like my power of 1. This is power of 3. Odd functions, right? Power of 4 is called a quartic. Like a quarter of a dollar. Any guesses as to how many x-intercepts I could have? Good guess. So depending on all this other stuff, I know it goes up here, I know it goes up there, but I could have 1, 2, 3, and if it's the best one you could possibly have, it looks like a W for Watson. That's the best polynomial. X is all real. Range, well, it'll be greater than or equal to the minimum, or just like this guy, less than or equal to the max, if this thing's reflected over the x-axis. Let's put a question mark there for the things. Power of 5, called a quintic. Is there this prefix in music somewhere, Will? Quintuplet? 5 guys play together, it's called a quintet. There we go. Right? Y is x to the 5 plus God knows what else. What quadrants does go up and down in? Just like x cubed, goes up there, goes down here. It could go 1, 2, 3, 4, could go 5 times. If I had all the nice little stuff, I wish there's one I could show you, but I don't have one written down right now that does that. Sometimes takes 20 minutes to find one. Domain, all real. Range, all real. Is that just like this one? Is that just like that one? It's an odd function. That's as far as we're going to go in our table. 100 is called a hectic, but that's Latin. If you want the Greek translation of the prefix, it's a spastic. But the point here is, what's the pattern? How many x-intercepts could I have with this? Yeah. Okay, I'm not going to draw it. Okay, that's all you get.